So it's very easy to generate Pascal's triangle. The numbers are very familiar to us and we know how to do this. We're going to start off with the vertex or the apex of the triangle with 1, and then we have another row. Row 1 is going to be formed by creating 2 1s, and then we have 1, 2, 1. Again, every row 1, row 2, and row 3 will be the sum of the two numbers diagonally opposite or adjacent to the next previous row. And so row 3 here is going to be 1, 3, 3, 1, which again is generated from the previous row in Pascal's triangle. Now, using numbers, it's easy to generate the values in Pascal's triangle, and we've done so for a large number of rows. So let's number the rows. We've got row 0, row 1, row 2, and row 3, row 4, row 5, row 6, and row 7, and row 8, and row 9. And you can see this goes on indefinitely. The rows just keep getting wider and wider. What's important to recognize is that each of these numbers in each row can be generated using the choose notation. With row 1, it's going to be 1 choose something. So I'm not even going to start with row 0. So row 0 always starts with 1. But row 2, the numbers that are in row 2 are going to be generated from the numbers of 1 choose 0 and 1 choose 1. So in row 1 we have 1 choose 0 and 1 choose 1, and those numbers are equivalent. Now let's take a look at row 2. Row 2 is going to be generated by using the numbers 2 choose 0 followed by 2 choose 1 followed by 2 choose 2. And I'm going to box those in because those numbers are equal to 1, 2, and 1. 2 choose 0 is equal to 1. There's only one way to choose 0 items from a group of 2. 2 choose 1 is equal to 2, and 2 choose 2 is equal to 1. Now let's look at row 3. Row 3 is generated from the values of 3 choose 0, which is 1. The next number in the row is 3 choose 1. Notice that I'm increasing the number that I'm choosing from. The next number after that is 3 choose 2. And both 3 choose 1 and 3 choose 2 have a value of 3 and 3. And the last number is 3 choose 3. So there's our values in row 3. So in row 3, it's always 3 choose something out of 3. In row 4, the numbers are going to be 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4 as being my outer number. So you can see that what's happening in each row is that the number that we are choosing from is getting larger. It's equal to the row number, and the number selected, of course, is going to be the K, and choose R, the R value. So again, the Pascal's triangle is symmetric along the along the middle, with the numbers on the left side equaling to the numbers on the right side of the triangle. So naturally, when I go down here to row 9, if I take a look at all of these numbers, that first number is 9 choose 0. The second number is 9 choose 1. The next number is 9 choose 2. The next number is going to be 9 choose 3, and followed by 9 choose 4. Then we have 9 choose 5, 9 choose 6, 9 choose 7, 9 choose 8, and 9 choose 9. 9 choose 9. And what you'll notice is that 9 choose 8 is exactly the same value as 9 choose 1. These two numbers are identical. 9 choose 6 is exactly the same as 9 choose 3. and so on. So we've got Pascal's triangle. Every row is going to be a function of some n value, the row number. And now I'm going to go back and talk to you about the oranges problem. And with the oranges problem, with one layer, we have one orange. Once we have two layers of oranges, we're going to have one layer at the top, and we're going to underlay 3 oranges underneath that, so we'll have 1 plus 3 oranges, or a total of 4 oranges. Now let's go to 3 layers, and we've discussed this already. So when we have 3 layers, we're going to have the 1 layer at the top, followed by the 3 layers underneath that, plus underneath that we will have another layer, but this time this other layer is going to have a total of 6 more oranges. So we're going to have the 4 layers here plus 6 more for the next layer. So we have a layer of another layer of 3 by 3 triangular layer of oranges. So it's going to be a total of 10. So we'll have 4 plus 6 more, which is a total of 10 oranges in 3 layers. And so when I go to 4 layers, I'll have all that I have up above plus another layer, which is, in other words, I will have the 10 oranges plus another layer that is going to be 1, 2, 3, 4, 1, 2, 3, 1, 2, and 1. And when I count those up, that's a total of 10 more. So it'll be 10 more plus 10 more. So 10 plus 10 gives me a total of 20 oranges. So this is great. So I've got 1 orange with 1 layer, 4 oranges with 2 layers, 10 oranges with 3 layers, and 20 oranges with 4 layers. So how many do I have with 5 layers? Well, in 5 layers, I'm going to have all of the 20 oranges. So I'll have 20 oranges below, plus I'm going to have another group of oranges that's going to be a 5 orange triangle. So we're going to have 1, 2, 3, 4, 5, plus 4 more above that, plus 3 more above that, plus 2 more, plus 1 more. So you can see what's happening here is I'm going to have the 20 plus I'm going to have another group of 15. So that's a total of 35 oranges. And we could follow the same approach now to figure out how many oranges we're going to have in 6 layers. Once you've figured out for n is equal to 6 layers, we will have a total of 56 oranges. And yeah, when you go back to the to Pascal's triangle, you can see that with Pascal's triangle these numbers do appear. In fact, I'm going to box them in. The numbers 1, 4, 10, 20, 35, and so on, they all appear right here. And that is one of the diagonals in the Pascal's triangle. And so what I'd like to do now is to say, okay, well, if it's these numbers here represent, in this diagonal, they represent the total number of oranges for each of the layers, I need to figure out what the choose notation or the choose values are for each of them. So, and I'm going to take another look at this Pascal's triangle to establish that. And so I've got 1 orange for 1 layer, 4 oranges in 2 layers, 10 oranges in 3 layers, and in 4 layers I've got 20 oranges. 5 layers I'm going to have 35 oranges, 6 layers I'll have 56 oranges, and 7 layers I'm going to have 84 oranges, and so on. What's the formula that's going to help me generate the number of oranges that I need for n layers in our tetrahedron. And so going back to our Pascal's triangle, we've got the original Pascal's triangle started off here on the left side, and I've filled in the choose notation for some of the rows on the right side of the column. And we would like to find the values that correspond to the diagonal, one of the diagonals. Well, which diagonal do I want to find? I want to find the diagonal that has the values 1, 4, 10, 20, 35, and so on. That's this diagonal right here. Okay, and so that diagonal corresponds to the diagonals that are along here. So we've got, let's see. So this diagonal is equivalent to the diagonal along here. Which, incidentally, you may notice that it is exactly the same set of values as the diagonal along here. So if I were to circle the other values, it would be corresponding to the values along this diagonal right here. So let me see what they are. So 3 choose 3. 3 choose 3 is equal to 1. The next number down is 4 choose 3. 4 choose 3 is equal to 4. The next number down is 5 choose 3. So we've got 5 choose 3, and 5 choose 3 is equal to a value of 10. The next number down, if you follow this diagonal, is going to be 6 choose 3. And 6 choose 3 is going to be equal to, when you work that out, 6 choose 3 will equal to a value of 20. And following the same pattern here, 3 choose 3, 4 choose 3, 5 choose 3, 6 choose 3, the next one obviously has to be 7 choose 3. And 7 choose 3 happens to be a value of, wow, I think it's going to be 35. Check it. The next one, according to our pattern, is going to be 8 choose 3 in our Pascal's triangle. And 8 choose 3 is going to be working out, or will work out to be a value of 56. So I think now we have a pattern, and we can spot the pattern in terms of how many oranges we're going to need depending on the number of rows. So now I think we're onto something here. So we can see that the number of layers is going to affect the number of oranges that we need. So with one layer we need this many oranges. With 2 layers we need this many oranges. With 3 layers we need 5 choose 3 oranges. With 4 layers we need 6 choose 3 oranges. Notice that the choose 3 doesn't change. It's always choose 3. But the first number is going to be 2 more than the number of layers. And so let me set up a pattern here. See if I've got it. So it's going to be 2 more layers. So the number of layers plus 2, something choose, and it always seems to be choose 3 when I go back to my table. So it's always choose 3, but it's the number of layers plus 2, because here we have 1 layer for the first value, and we have for the second value we have 2 layers and 3 layers and so on. So let me just test this and see if this is going to work out. So if I've got 1 layer, and I'm going to end up with, let me see now, n plus 2 choose 3, and n plus 2 choose 3 will equal 1 plus 2 choose 3, and 1 plus 2 choose 3 is 3 choose 3, and 3 choose 3 is equal to 1. So it works for 1 layer. Now let's check it out for 2 layers. For n is equal to 2 layers, we're going to have 2 plus 2 choose 3, or in other words 4 choose 3. And 4 choose 3 is going to be equal to a value of 4. So it works for 1 and it works for 2. Now let's see if it works for 3 layers. So for n is equal to 3 layers, what are we going to have? We're going to have 3 plus 2, 2 more, choose 3. And 3 plus 2 choose 3 is 5 choose 3, and 5 choose 3 is equal to 10. So it works for 3 layers. Now let's see if it works for 4 layers. N is equal to 4 layers. We've got 4 plus 2 choose 3, and 4 plus 2 choose 3 is equal to 6 choose 3, and 6 choose 3 is equal to 20. So it works for the first 4 layers. Let's just double check and see what it works out to for n is equal to 5 layers. At n is equal to 5 layers, we're going to have 5 plus 2, 2 more, choose 3. And 5 plus 2 choose 3 works out to be 7 choose 3, and 7 choose 3 works out to be a value of 35. Wow, we're on to something here. Bingo. I think we've got it. So if I have 10 layers of oranges, so for 10 layers, we're going to have 10 plus 2 choose 3. And 10 plus 2 choose 3 is equal to 12 choose 3. And 12 choose 3 is equal to what number? This is the number of oranges that I'm going to need for 10 layers. Work this out.